بسم الله الرحمن الرحيم. يلا يعطيك العافية. We was talking last time about forces and we said that it's an outside effect. Okay, it's an outside effect. What this outside effect? It try to change. Try to change what? Try to change. Okay, no problem, Salma. No problem, Salma. Try to change one of the two things. يا إما motion state to change it, or to change what? The shape of the object. Okay, and we said that when we talk about forces, okay, we wrote that in details. Okay, we said that when we talk about forces, we talk about two things: changing motion or changing shape. And we said, good evening, Allah يعطيك العافية. And when we said about changing motion, okay, we said that we have three ways to change the motion. What are these three ways to change the motion? The three ways to change the motion are speeding up, or slowing down, or change direction. So we say that there is speeding up, or slowing down, or what? Change direction of motion. Change motion, direction of motion. And three of these together, we call them what? Acceleration, right? Right? Okay, so, tamam. And I asked you to do these questions as homework. Some of you sent it to me, others they didn't. Okay, no problem. Okay, احنا وصلنا لحد هون مظبوط لعند هدول questions. We didn't answer them. Did we? Did we answer these questions together? Can anyone tell me if we answered them or not? Because I have get confused now. Yes, we have all of them. Shukra Abdurrahman, all of them, right? Even these. Question 8, we did question 7 and 8. These multiple choice questions. Not at all. طيب خلاص خلينا ايش, let's do them again from beginning. Okay. Now when they say that a train is traveling along a horizontal track at what? Constant speed. When they said constant speed, that means it is what? Balanced. When they said it's balanced, that means the resultant force equal how much? Equals 0, since it's moved at straight line. The two forces act on the train as shown in the diagram. The force of air resistance also act on the train, give a resultant force of 0. They give us the idea that the resultant force is 0. There is no resultant force. What is the air resistance? As you can see, okay, this is what is the train. Okay, we have a force from the engine, 60 kilonewton, and a friction force backward of 20 kilonewton, 20,000 newton. That means we know that the air resistance acts in the opposite direction of the motion. So in which direction does the air resistance act? Forwards or backwards? Yeah, tell me on the chat if you please. The air resistance act as the train is moving forwards. In which direction does, yes, Ibrahim, thank you. Okay, who else can give me the answer? The air resistance acts where? Aya Shabab, acts what? Backwards. So the answer here, it would be 40,000 Newton what? Backwards. So the answer is what? Yes, Shukran Muhammad. The answer is what? The answer is 40,000 Newton backwards. So 40,000 plus 20,000, it will be 60,000 backwards, and 60,000 forwards make the resultant force equal how much? 0. So there is no resultant force, right? Good. If you understand it, if you please show me your thumb. Put thumb ups, if you please. Okay. اوكي هاي عندي انا اثنين رافعين ايديهم. who else؟ 3. تمام. اوكي هلا اوكي good. most of you رافع ايديه. شكرا لكم. lower your hands. Okay. تمام. Now next question. What they said here? They said that a force acts on a moving rubber ball. So there is rubber ball. We can squeeze it by a force. A force act on a moving, that means it was in motion. Okay, how many of the following changes could happen because of the force? Can it change its direction? Yes, it can change its direction. Okay, خلينا نظبط هاي. Okay, شكرا. ظبط هاي يلا. Okay, so as you told me, yes, it can change the direction, it can change the shape, it can change the speed, but it cannot change the mass of the object. So the answer is C, 3 out of what of these 4 the force can do. In question number 3, what do we have? We have 3 Newton forwards and 2 Newton backwards, or 3 Newtons. How can it change the speed? Yes, it can change the speed. I can kick it to increase the speed or slow down the speed of it as I hit it by a force. So the force on a rubber ball, when there is a force on the rubber ball, it can increase its speed in the same direction or reduce the speed in opposite direction to act. For example, if this is the rubber ball and the rubber ball was moving in this direction, if I make a force in the same direction like this, that means I kick it in this direction. That means I'll speed it up. But if I make a force in the opposite direction like this, that means I'll slow it down. I can also change what's its direction as I hit it from sideways. So instead of moving to the right, it will move a little bit right and up. So it changes direction this way now. Good, Ilaf? Good? Okay, no problem. Tamam. Here, what this said. Okay. An object, okay, as shown here, there is 2 forces acting. A 3 Newton force act to the right. That's why they put a longer arrow. That means it's bigger force. And what? 2 Newton to the left acts from the right to the left. That means if this is the object, there is 3 Newton acts to the right, and there's 2 Newton acts where to the left. So there is a resultant force, right? In which direction is the resultant force? It will be to the right because the 3 Newton is bigger than the 2 Newton. So there will be 1 Newton resultant force from 3 minus 2 to the right. So which one is the answer? Send me the answer on the chat if you please. All of you, yes. كلياتكم ابعتوا لي الانسرز لو سمحتوا. أدهم، حازم، إبراهيم، ليث، محمد خالد، ريما، سلمى، يوسف، عبد الرحمن. Send me the answer. Yes, exactly. So the object will move to the right, but there is a resultant force. So the answer will be what? With acceleration or with the constant speed? When they say there is constant speed, that means the resultant force is supposed to be equal how much? It's supposed to be equal 0. But here the resultant force is what? Is 1. So there is a resultant force. So which one is the answer? The answer is D. The answer is D. Thank you. Thank you. شكرا. شكرا إلاف. شكرا أدهم. شكرا محمد. Yes. إبراهيم. برافو عليكم. شكرا لكم. Good. Next. An airplane is in equilibrium. Equilibrium means balanced and stable. We are going to talk about stability later on. So it is balanced, okay? So the diagram shows the forces act on this airplane, okay? So we have force from the engine forward to the left. We have air resistance to the right, opposite in the direction of the motion. We have a lift force from the wings upward, and we have the weight of what? Of the airplane downwards. Which statement about forces are correct? Yeah, send me the answer. Which one of these forces, which one of these statement about forces is correct? Send me the answer. يلا. شكرا يا حازم. برافو. إله. فكري مرة تانية. Okay. Send me the answer. يلا. مصطفى، ليث، مروان. Send me the answers. Okay. مروان مش موجود. Okay. مش مشكلة. Who else? يلا. Send me the answers. شكرا يا سلمى. Okay. Now, because we said it's balanced, that means the resultant force equal also how much? 0. So the forces forward and the forces backward are equal. The forces up and the forces down are also equal. So the force from the engine is equal to the air resistance, and the lift force is equal to what? To the weight. So the answer is what? A. طب أستاذ كيف بتطير الطيارة؟ أكيد بتطير الطيارة. كان في resultant force. كانت الانجن of force أو lift force more than the weight and the air resistance. There was more. That's why it's going up. But after it reached a high speed, okay, sorry, high altitude, it reached a constant speed. Now, because it's moving now at constant speed. So it doesn't need that it will accelerate or decelerate. So the resultant force is how much? Is 0. Good? Tamam. So the answer is A. Question number 5. The force of gravity acting on an astronaut is an orbiting spacecraft is less than she is on the Earth's surface. Okay? Compare with being on the Earth's surface. How do her mass and weight change, okay, when she goes into orbit? Tell me the answers. Mass doesn't change. Bravo. صح. Okay, Salma. تمام. Bravo, Ilaf. Excellent. Excellent. You know the answer. شكرا يا حازم. Okay. So the mass unchanged, but the weight changed, decreases. So the answer is what? Is C, because the weight is the gravitational force. And whenever you are far from the Earth's surface, that means it will be less what? Less gravity. Oh, look what they said. The force acting on an astronaut in orbiting space is less. So what that means, the weight, it will be less, decreases. Tamam? Okay. Next question. Question number 6. An aircraft flying at constant what? Height with gaining speed. That means there is what? Acceleration. The gaining speed. That means there is acceleration in the direction of what? Of the thrust force. Okay? And constant height, that means it doesn't go up or doesn't go down. That it means it's balanced vertically. Okay. The 4 forces acting on it is lift, air resistance, thrust, and weight. Which row is correct? Which row is correct? Muhammad بعت لي اوكي وإلها اوكي okay, bravo عليكم. The answer is C, exactly. The lift and the weight, they are equal and balanced. Okay, so the vertical height remains the same, but because there is acceleration forward, that means the thrust is more than the air resistance. Bravo عليك يا إبراهيم. شكرا يا أدهم. شكرا يا صبايا. Good, bravo. Next. A car of mass 1,500 kilogram, 1,500 kilogram, is towing of what? A trailer of mass how much? This is the second mass. So we have M1, mass of the car, and we have the trailer, okay? Mass of the car, mass of the trailer, okay? 1,100 kilogram. Along a level road. Level road, that means horizontally, okay? That means it doesn't go downhill or uphill, okay? There is no effect of the weight. The acceleration of the car is how much? 1.3 meters per second square. Ignore friction or air resistance. There is no other what forces. What is the driving force on the car? Now we know that resultant force equal what? The driving force, the thrust force, minus friction and air resistance. There is no friction or air resistance. So the driving force equal mass multiplied by what? Acceleration. Now, is the mass the first mass or the second mass? Is it the mass, the first mass or the second mass? The mass of the car or the mass of the trailer? Or the mass for both of them? Exactly, the mass of both of them. We cannot neglect that. Yes, exactly. So the mass of the car, 1,500. Okay, let me repeat this. The mass of both of them, because they are towing to each other. The mass of the car plus the mass of the trailer multiplied by the acceleration for both of them. So the driving car, okay, the driving force on the car equal 1,500 plus 1,100 between brackets multiplied by how much? 1.3, and the answer will be how much? Yes, in this situation, how much is the answer? The answer is exactly 3,300 watt in Newton. So the answer is D. Good. Again, when we are talking about I have a mass, okay, for example, 90 kilograms, and we have what? I have a bag on my back, okay, and this bag, for example, other 20 or 30 kilograms. That means my total mass increased, so I need more force to accelerate. So that's why I add I add both masses together. تمام؟ شكرا يا أدهم. شكرا يا عبد الرحمن. Next, question 8. A geologist, okay, places a small rock on the left-hand pan of the balance. The two pans are level, okay, as known when masses with total weight of how much? 28. So this rock, they put it on the left side, and we put as masses here with load of what? 23 Newton are placed on the right hand of the pan. Take that the weight of each 1 kilogram is 10 Newton, okay? What is the mass of the rock? Now, exactly, weight equal mass times gravity, okay? Gravity acceleration. And since they are balanced, that means they have the same force, they have the same weight. So the mass equal the weight, which is 23, divided by the gravity acceleration, which is 10, okay? And the answer will be 2.3 kilogram. So the answer is B, 2.3 kilogram. شكرا يا إبراهيم, شكرا يا حازم, برافو عليكم. Excellent. Question number 9, we did it last time. Question number 10 was homework. So question number 8, the answer is B. Let's move on to question number 10. What they ask? What do we have? They say that the figure below shows the speed time graph. This is speed, this is time. Okay. Graph for a bus during what tests? We have two tests, test 1 and test 2. At time t equals 0, the driver starts to brake, to slow down, brake. So there is slowing down from instant 0 to whatever the time it is. For test 1 alone, for test 2 alone, okay? Now for test 1, that means they ask only for test 1. They didn't ask for test 2. They ask for 3 things. Determine how long they need to stop, okay? They ask about the time. State which part of the graph has the greatest deceleration, okay? That means they ask about slope. Okay, use the graph to determine how far the bus traveled in the first 2 seconds. That means they ask about area. Again, I told you last time and several times, in any graphs, they ask about 4 things. They ask about four things. The XY coordinate, the values from them. Number 2, the description or the explanation or the relationship in the graph. Okay, depends on the question. The description or the relationship of the graph. Number 3, the slope, the gradient. Number 4, the area. Now what they ask here, what do we have? They said in the beginning here, Bismillah ar-Rahman ar-Rahim, determine how long the bus takes to what? To stop. Now, as you can see for test 1, from P to Q, then from Q to R, it took the bus how many seconds? Exactly 7 seconds, 7.0 second, 7.0 second, 2 significant figures. مرات ما بيكون كاتبين 2 significant figures, no problem, بس مرات they want 2 significant figures. Mister, can you close the share screen to repose? It's delay or confuse me. Okay, أنا آسف. هلا بعمل share مرة ثانية. خلينا نشوف. بسم الله. اوكي نشوف هلا هيك تمام الوضع ان شاء الله. هلا بنشوف. Okay, so what do we have? We have test 1. Okay, this is test 1 from P to Q to R, and they ask first question to determine how long the bus takes to stop. So they ask about the time from 0 to how long does it need to stop. Okay, how long does it take to stop? تمام. State, next part, double I, state which part of the graph has the greatest deceleration. Is it from P to Q or from Q to R? Which one? Now, when they ask about acceleration or deceleration, they ask about the gradient. Which one has the more gradient? From P to Q or from Q to R? What do you think, Shabab? From P to Q, 2 seconds, or from Q to R, 5 seconds? QR, because it takes longer time. عبد الرحمن, طيب, حازم, اوكي ها في ناس بيحكوا P to Q في ناس بيحكوا Q to R. Actually, whenever the gradient is steeper, whenever the line is steeper, let's imagine that we have this is PQ and this is what QR. Which one is steeper? Which one has a more gradient? Which one? Which one is steeper? That means it's not horizontal, it's more steep, more going down. From P to Q, exactly, P to Q. Why? Because as you can see, it goes down in 2 seconds. How much? 8. But Q to R in 5 seconds from 2 to 7, okay, it goes only 7 goes down. This is 7. Okay, it goes down 7. So that means the slowing down or the deceleration is less from Q to R. So it will be greater from P to Q. Okay, whenever the line is steeper, that means the deceleration or the acceleration, it will be more. Next, use the graph to determine how far. They ask about the distance. When they ask about how far, the distance, which is we know as area, in the first 2 seconds. This is the area. What this area called? What this shape called? Who can tell me what this shape called? Trapezium, trapezoid, trapezium. Who? The area of this trapezium or trapezoid, exactly. Yes, bravo. So how can we find its area? Who can remember what's the area equal? It's
me.
Yes, tell us. A plus B 2 multiplied by what? H, right?
No, I think it's half A plus B times H.
Bravo. Half A plus B or A plus B divided by 2 multiplied by what? H. So A is the height here, which is only 7, plus B, which is the height here, which is 15, divided by 2, okay, multiplied by what? The time or the height from here to here, which is 2. And by using the calculator, the answer is 22 what? Meters. Can I divide the trapezium into triangle? And yeah, you can. If I do that, if I did as Adam said, if I divide the shape into what? A triangle and a rectangle. Now I have to do what? And I will get the same answer. 2 times what? 7. This is the height, plus this is the triangle. Okay, rectangle, I'm sorry. Plus the what? A triangle. And the triangle is half base height. So 2 times the height. How much is the height? Some students, they do a mistake and they put 15. No, actually it's not 15. It's the distance from here to here, which is what? 8. So by doing that, 14 plus 8 to cancel out each other, we get the same what? We will get the same answer. So it's your decision what you are going to do. So that's why I do the fast method, okay? I do the fast method. I find the area, all of it directly. I didn't divide it, okay? But you can do, if you want to check, you can divide it into what? Triangle and rectangle. So this is the rectangle here, okay? Which is 2 times 7 plus what? The right angle triangle, which is half times base 2 times height, which is what? 8, from 7 to 15. Good? You can do that. Yes, exactly. Let's continue. All these questions was in part A for test 1. Okay, Ilaf. My teacher said that we should write on the horizontal line, but 1 steps. Why? When it comes to solve problem. I didn't understand your question. We should write on horizontal line, but 1 steps. مش فاهم عليك. If you want, send me a voice record, okay, on the WhatsApp, so I can hear what you want to say, okay? تمام، خلينا نرجع نشوف شو اللي عم بصير معنا هون. Okay. Now that's for test 1. We find the time. How long does it need to stop? 7 seconds. we decide which one has greater deceleration from P to Q because it's steeper than Q to R. We find the area, the distance traveled only in the first 2 seconds by the whole area under the shape of trapezium. That's for test 1. Okay. For test 2, now, a device was fitted, okay, to the bus. The device changed the deceleration state. That means you know the answer. State 2 ways in which the deceleration during test 2 is different from what during test 1. How can we say that test 2 is different than from test 1? How can we say that? Yes. Who can tell me? Look here to the graph. Why test 2 is different than test 1? What about this point? Test 2 is constant or uniform deceleration. طيب, ماشي. But test 2, it takes what? Same time or longer time? Exactly, Hassan. Bravo. Test 2 cover more distance and takes longer time. As you can see, bravo, Hassan. As you can see, it is 8 seconds, not 7 seconds. And the area under the graph for test 2 is more than the area under the graph for what? For test 1, this one. So that means test 2, okay, takes longer time and it takes more distance to what? To stop. Bravo يا حازم. شكرا لك. Yes, exactly. طيب إذا هذول 3 answers. أنا حكتب هلا 3 of them. أول شيء test 2 took longer time to stop. Number 1. Number 2. Test 2 covered longer distance to stop. Number 3, test 2 was one uniform deceleration. Now, if I were in the exam, I will answer the first 2. I will not answer the third one because I'm not sure about the mark scheme. But if I have enough time, shall I write 3 of them? Yes, write 3 of them. They will accept the answers. Okay? Yes. شكرا يا عبد الرحمن. Bravo. شكرا يا محمد. Excellent. Last part in this question. That was your homework. Double I. Calculate the value of the deceleration in test 2 from 0.15 to 8.0. They ask about what? The gradient of the deceleration here. So the deceleration, which is equal to the gradient or the slope. Now, it doesn't matter if it's positive or negative because they ask about deceleration, which we know it's a negative acceleration, but we are not going to write it down like this. So it's change in velocity divided by change in time. So it's 15 minus 0 divided by the time, which is how long does it take? It takes 8 seconds. So 8 minus 0. And the answer will be 1.875 meters per second watt square. You can write, if you don't want, you can write 1.9 meters per second square. That's 2 significant figures. So it doesn't matter which one is their answer, both are accepted. So you can write 1.875 as you found in the calculator, or 1.9, 2 significant figures. So again, what we did here, we find the gradient. We took the point of 15 and the point of 8. That's what's the line. What's the coordination here? It's 0.15. 0.15, and what's the coordination here? It's 8.0, and we find the rise over the run. What about the 3 significant? Yes, you can write 3 significant figures. Also, you can write 1.88, no problem. Of course, no problem. Salma. تمام? It's your decision. Okay. Next. Any question? That was your homework. طيب نيجي هلا نكمل هون. Oh, this question. It was a long question. We didn't finish it last time. شو بيحكي لنا هذا السؤال؟ بسم الله الرحمن الرحيم. مرة ثانية. A solid plastic sphere falls towards the earth. The speed time graph shows how it's the velocity of it, the speed of it until it hits the ground surface. Because they say the plastic, that means it's affected by air resistance, and as you can see, it's not straight line, it's curved. That means there is a uniform acceleration, okay, here. Then there is decreasing acceleration. The acceleration decreases, okay, and eventually RST, okay, until it reached the terminal velocity, or until it reached a constant speed. So there was acceleration here. The acceleration was equal to g. Then the acceleration was less than g. Then the acceleration equal to how much? To 0. Okay. Now we did this several times. It doesn't matter. So again, ya shabab, in the beginning here, the acceleration was equal approximately g. Here the acceleration is less than g. As the speed increases, air resistance increases. Eventually, here the acceleration is equal to how much? To 0. There is no acceleration. Okay. Then what they ask, on the figure, draw arrows to represent the forces act on this plastic sphere as it falls. I did do only on one point, the S point. I did it in several points. After 2 seconds in the beginning here, after 20 seconds here when the acceleration is less because there is air resistance, and at S here. So in the beginning there is only weight, then there is weight and air resistance, and the air resistance is less than the weight. Then there is air resistance and weight, and they are equal. The weight doesn't change, but the air resistance increases. So that's how we can answer a question of 5 marks, not only 2 marks. 1, 2, 3, 4, 5 marks, 5 points at 3 different positions. Then what they ask, C, explain why the sphere is moving at a constant speed s. Why the sphere is moving at constant speed? Let's return back to the graph. They give us an answer here. Constant speed. That means you can write here from R to S to T, it is constant speed, the terminal velocity. So they give us the answer. Why does it move at constant speed at point S in this region? Because the acceleration equal how much? 0, because it was moving at constant speed, because the resultant force from the air resistance and the weight, it's how much? It's 0. So some students, what they do? They write that the air resistance is equal and cancel the weight, make the resultant force is 0. All this is 1 mark. The second mark, you have to mention about information about acceleration. How much is the acceleration? Also 0. So when we write air resistance cancels the weight, making no resultant force, that's a mark. And no acceleration, okay, that's another what? Another mark. So the answer, there is no air resistance, there is no acceleration, and there is no resultant force. وصل لي خبر انه الفيسبوك والواتساب خلال اليومين الماضيات فيه مشاكل، فعشان هيك مش عم بزبط التواصل بين بعض الدول الخليج، خاصة مع الكويت والإمارات. الله أعلم شو مصداقية هذا الخبر، بعرفش ليش هيك بتعمل شركة فيسبوك، بس خلص. أوكي نكمل. تمام. Use the graphs to what? To calculate the approximate distance that the sphere falls. Use the graph to calculate the approximate distance, okay, that the sphere falls from R to T and from P to what? To Q. Now let's return back to the what? To the graph. From R to T, it's moving at what? At constant speed, right? How we can find the distance? Yeah, send me the answer. Ah, Hazem, bravo عليك. Because it was moving at constant speed, we can find distance equals speed times time, and the speed is 120, and the time from 60 to what? To 100, okay? Or we can find the area. Can we, Hazem? Yes, of course we can. So they ask here from R to T, that means distance equal the area, or you can say speed times time because it was moving at constant speed. So on both answers, it's 120 multiplied by the time, which is 100 minus 60. And the answer finally, it will be 4,800 what? meters. شكرا يا حازم. اوكي نكمل مرة ثانية هون مرة ثانية. From R to S to T, it moves at what? Steady, constant speed. How much is the speed? 120. We can find the distance by finding the area under the graph from 60 to 100 seconds, this area, okay? Or we can use the formula distance equals speed times time. So in both ways, we get the what? We get the correct answer. Tamam? Good? Okay. So that's how we can find the distance between R and T by finding the area under the graph, or finding what? Using the formula speed times time. What about the next part here? What do they ask? خلينا نغير اللون يكون هيك شوي واضح. Okay. Between P and Q, look here. Between P and Q, if I look to the graph, between P and Q, as you can see, it's uniform acceleration. And the Q, it reached here after 2, 4, 6 seconds, 8, 10. So that the base here of this right angle triangle is 6 seconds. And the Q is exactly in the middle between what? 40 and 60. So how much is the height of this triangle? It's what? 50. So شكرا يا حازم, bravo عليك. So to find the distance from P to Q, you can say that I will use the formula of the area under the graph, okay? Or I can use the formula U, which is 0, plus V, which is 50, divided by 2, multiplied by what? The height. I'm sorry, multiplied by the time, okay? Which is what? 6 seconds. In both ways, or finding the area, which is base 6 times height 50, divided by 2 half base height. In both ways, we get the same answer, which is how much? 150 what? Meters. 150 what? Meters. شكرا يا حازم. شكرا يا إلاف. Bravo. يا سلام عليكم. Excellent. Okay, good. Now, as you can see, we find the distance, approximate distance from R to T, from P to Q. Triple I. Use the graph to calculate the approximate distance that the sphere folds between R to T, between P to Q. Let's do the triple I, the whole height, the whole distance, the whole height, the total height. How we can find out the total height? How we can find out the total height? Let's turn back here. Look here, ya shabab. What we did here, we find this area, which is how much? 150. We find this whole area, that is how much? 4,800. Okay. Now what do we need? We need to find this area that left, right? شو نعمل? Who can give me ideas? What we will do? حازم كاتب add them together. Okay. كيف يعني add them together? برافو عليك. شو نعمل? What do we need to do? For يعني I add this one, okay, plus this one, that's it. Or I need to find also the area here, this area. Exactly, yes. I need to find this area also, and I will estimate how much is this area approximately? How much is this distance? I will estimate it. That's why they did ask to calculate it out, to find it out approximately, to estimate the amount. So I want to from you, Ya Shabab wa Sabaya, to try to do this part that I did as a homework. Then I add the whole thing. So this one, this part that I wrote it now, the total height, I want from you to estimate it, estimate the total height. Okay, this is your homework for next time. I want to see who get the correct answer. Mashi? Who can get correct range? There is range of the accepted answer. Okay, and we need to see who can get this range of the accepted answer. I'm sure that all of you can get the correct answer together. Mashi? Okay, this is your homework. This is one of the homeworks. Let's go on to question 12. Question 12, what they ask. A stone falls from the top of a building and hits the ground at speed of 32 meters per second. Shabab, how many information this line give us? Yalla. How many information? Write the information that the question give us. Send it to me. Yalla. What are the informations that this question tell us? Here, only the first line. What this information? What are the informations? How many knowns or unknown or given the question ask? How many given the question give us? Which is speed and which time? Yes. محمد بيحكي speed and time. حازم بيحكي T equal V. لا يا طول بالك يا حازم. طول بالك. Answer my question. Yes. No, they didn't give us the time. يا محمد. No, they didn't give us. A stone falls from a top of building and hits the ground at speed of 32. Where's the meters per second? Where's the time? There's no time here. Speed and distance. Okay, which one is the speed? This one is the speed. If this one is the speed, where's the distance? They didn't give us a distance here.
But it says speed time.
Listen, hold on. I'm asking about this line that I underline it here. How many given this line give us? Gravitational force. What do you mean by enough gravitational force? Is there weight here? Is there weight? طلع.
Speed.
This is speed, of course. This is V. What do I mean by V? This is final speed. عن جد؟ معناته أعطانا initial speed. Yes. The stone falls or dropped. That means the initial speed U is how much? Is 0. It's not a thrown. It's a dropped. It's falls. So it starts from initial speed is 0. And also, exactly حازم, مش gravitational force, gravitational acceleration. The acceleration of falling, A, it's how much? 10 meters per second square. So as you can see, this word give us two hidden informations. The initial speed is 0, and the acceleration is the acceleration of free fall because it falls by its only weight, which is how much? 10 meters per second. And V is the final speed, how much? 32. So they give us three information in this line. The word falls give us two information, that the initial speed is 0 and the acceleration is what? 10 meters per second square here on Earth. Tamam? Okay, let's continue. Air resistance force is very small and may be neglected. We can neglect it. We can ignore the air resistance. Calculate the time of fall. Calculate the time of fall. Now we know that acceleration equal V minus U divided by T, right? Can I switch the A and the T? Can I do cross multiplication to find T as subject of the formula? Of course I can. And you can, okay? So time equal what? V minus U divided by what? Acceleration, as Hazem told us now. So the final speed, which is 32, minus the initial speed, which is 0, divided by the acceleration, which is 10, and the answer will be how much? 3.2 seconds. So this stone needs 3.2 seconds to reach the ground and hit it. مرة ثالثة يا شباب. The word falls give us initial speed equals 0, it's not thrown, and the acceleration is the acceleration of free fall. These two were two of information, two given. I just know it by the word falls. And they say the stone, and they say there is no air resistance, okay, negligible. So that's why the acceleration is 10. And the speed of impact is the final speed. The speed of impact with the ground is the final speed, which is how much? 32. So this line gives us three information, and they ask about the fourth, which is the time. So acceleration equal v minus u over t. I will use it to find the time, which is how much? 3.2. Okay? Okay. On the figure below, draw the speed time graph for a falling stone. Now, we know that it starts from 0 by understanding that it falls. And after 3.2 seconds, this is 3.2 seconds, okay, it reaches a speed of how much? 32. Okay, so that means this line until this point, this is 32 by the intersection after 3.2 seconds, and it will be uniform acceleration. I will draw a straight line by ruler like this. This line by ruler, okay, Shabab? I'll draw a straight line like this. This is uniform what? Uniform acceleration. How much is the acceleration? It's 10. It's 10 meters per second square. So this is a straight line by ruler يا شباب لو سمحتوا. By ruler. Draw it by ruler, okay? By ruler. And by pencil if you have. If you don't have a pen, you can draw it with a pencil, okay? So it will be 32 after 3.2 seconds. That's the speed, and it will start from 0, and I draw a straight line. Part C of this question. The weight of the stone is 24 Newton. Calculate the mass. Tell me, how much is the mass? Yalla, send it to me on the answers. How much is the mass of this stone? Yalla, Muhammad. Bravo عليك. إبراهيم. برافو عليك. يلا إبراهيم. يلا معك حازم. شكرا يا حازم. برافو يا محمد. كويس إنك كملت كيلو جرام صح؟ في ناس سلمى. أيوة. ها. It's obvious. It is obvious. It is easy. الحمد لله في علامات سهلة. Weight equal mass times gravity, which is 10. So mass equal weight divided by gravity. So 24 divided by 10, and it will be what? 2.4 kilograms. It will be 2.4 what? Kilograms. Okay? Tamam. Ilaf. We divide by 10, not multiply by 10 to find the weight. Tamam? Okay. شكرا يا إبراهيم. شكرا يا أدهم. شكرا for all of you. Let's move on to question number 13. In this question, what do we have? A force acting on the object causes the object to accelerate. No informations. They say there's a force and there will be an acceleration. Okay. In which direction is the acceleration? Now we know that the acceleration is directly proportional to the force. As the force increases, the acceleration increases. But at the same time, the force and the acceleration, they are in the same what? Direction. Yes, Ibrahim, شكرا لك. Yes, في مشاكل في الإنترنت. Yes, شكرا لك. The acceleration and the force, they act in the same direction. So in which direction is the acceleration? In which direction? What's the answer? Same direction as the force. Same direction as the force. If the force is to the right, the acceleration is to the right. If the force is upwards, that means the acceleration is upwards. If the force is downwards, that means the acceleration is downwards, and vice versa, etc. Good? Tamam? That's part A. Any question? Part B. Any object move in a circle, we didn't study circular motion yet, but any object move in a circle has a force acts toward the center of the circle. What does this force do? شو بتعمل الفورس? What does the force do to this object? We said that the force can do three things. Three things the force can do. It can speed it up, it can slow down, it can what? Yes.
Change its shape.
Change. For motion, it can change its shape, but for motion, it can change. Bravo, it can change direction. So what does force do? Change direction of motion. Change direction of motion. Mr. Can you repeat since I got disconnected? No problem. Which part do you want to repeat? 13 from beginning or before? Here? Okay. Question 13 from beginning. Okay. There is a force act on the object, and this force make the object what? Accelerate. What will be the direction of the acceleration? The same direction as the force, because if the force is to the right, the acceleration is to the right. If the force upward, the acceleration upward. So the direction of the force and the direction of the acceleration, they are the same direction. So that's why the answer, same direction as the force. Good? تمام, part A. Part B. Now we have circular motion. And there is a force act on this circular motion, okay, on the object that moves in circular motion. This force acts to the center. We didn't study circular motion yet. But what actually this force do? It only does one thing. Change the direction of the motion. Instead of being a straight line, it's now circular. Good? Okay. Tamam. Next. Part C. It's a long part. C. I, 1, 2, double I, triple I, IV. 1 mark, 1 mark, 2 marks, 1 mark, 1 mark. It depends on everything here. Look what they say. Careful, okay? What do we have? A woman of mass 60 kilograms stands in a lift in a shopping center. Part I, that means only this, part I. Double I, it's something else. Now we are going to use the 60 kilogram for the whole question. But part I, they say that the lift is at rest. At rest means balanced or not balanced? Balanced. Means the resultant force equal how much? The resultant force equals 0. شو يعني resultant force equals 0? That means forces up and forces down equal and cancel out each other. What they said. State, that means you already know the answer. State, that means you already know the answer. State the value of the weight of the woman. How much is the mass? Exactly. So the weight equal mg, which is what? 600 Newton. شكرا يا حازم. 600 what Newton? 60 multiplied by g, which is 10. So 600 what Newton. That's the weight of the woman. Now this is the woman. Okay. And she's where? She's on the left. She's in the left. Okay. What are the forces acts on her? There is the weight that acts down, and we just find it out. 600 Newton. And there is what? Normal reaction force from the floor of what? Of the lift acts where? Upwards. Now this normal reaction force, state the value of the force exerted from on the woman by the floor. They call it normal reaction. They use letter R or letter N to represent it. What do you think? Is R bigger than 600 Newton or smaller than 600 Newton or equal to 600 Newton? They said it's at rest. So which one is the answer? Yalla, send me the answer. How much is R? How much is it? State? That means you already know the answer. State the value of the force exerted on the woman by the floor. How much? Yalla, send me the answers. I know that there is a problem in the internet here. I hope that you can tell me the answer. Shabab, it's also 600 Newton. Why it's 600 Newton? Thank you, Selma. Why 600 Newton? Because the forces up and the forces down are what? are equal. So because the object is what? At rest, it's balanced, the resultant force equals 0. So the weight downwards, 600 Newton, equal the force from the left, okay, upwards on the woman. And these forces are equal, so 600, 600, exactly. Shukran. Muhammad, this is the answer for the next question. Next question, what they said, double I. They said calculate the force, okay, required, that means the resultant force. The force required to accelerate the mass of how much? 60 kilogram by how much? By 2.5. Now we know that the resultant force equal how much? Equal mass multiplied by acceleration. How much is the mass? It's 60. Multiply. How much is the acceleration? 2.5, okay? And the answer will be 150 Newton. This is what, no problem, Muhammad. This is the resultant force. The resultant force, the force that makes the acceleration of 2.5 is 60 times 2.5, so it's 150 watt in Newton. Good? تمام؟ طيب. Triple I. The lift accelerates upwards at how much? 2.5. Now this is the lift. It was at rest. Now here it's not at rest. It's accelerating where? Upwards. Okay, there is acceleration upwards. That means what? That means the weight on her that doesn't change is equal to how much? 600 Newton. But the force of normal reaction will be what? Will be greater. Why it will be greater? To make the acceleration. So it will be how much? Upwards, more than the weight. How much does it? They ask. Calculate the force exerted on the woman by the floor when the lift is accelerating. How much do you think the lift force will be now? How much the lift force, the normal reaction lift force will be now? It was 600. Now it becomes how much? Exactly, how much? It will be now 750. So we know that the resultant force equal the lift force, R, the normal reaction, minus the weight. Okay, now the resultant force, which is 150, the normal reaction, which is unknown, minus the weight, which is 600, doesn't change. That means the normal reaction force equal the resultant force that we just find it out in double I plus the weight. So the answer will be 150 plus 600. So the answer will be how much? 750 in Newton. نعيد مرة تانية. Again, now when the lift was at rest, the normal reaction and the weight was equal because it's balanced. We need to find the resultant force on 60 kilogram when it's accelerated by how much? 2.5. So the answer, mass times acceleration, 150. This is the resultant force to accelerate 60 kilogram, the mass of the woman, of the lady. Now here they said that the lift accelerates upwards. Now when you are in the lift, okay, and the lift starts to accelerate up or accelerate down, you feel that there's extra or less force on your feet, okay? And if, for example, if you bend your legs and you are standing on the lift, okay, you can feel and see that as the lift is going up or down with acceleration or deceleration, you can see that your body is start to move up and down. You can also put a balance scale, analog balance scale, okay, analog, not digital, on the lift and step on it, stand on it, and you'll see that whenever the lift is going up and down, your weight will change. The reading on the scale will change. Why the reading change? Because the reading is the normal reaction R. So because the lift is accelerating upwards, that means the upward force is more than what? The downward force. The downward force is the weight doesn't change, 600 Newton. So how much the new normal reaction it will be to make the same acceleration as before? That means the resultant force, we just find it out, 150 equal normal reaction up minus weight down. So rearrange this, move the W, negative W to the other side. So it will, the normal reaction equal resultant force plus weight. The normal reaction equal resultant force plus weight. I move the weight to the other side. Okay, so the weight, which is 600, plus the the resultant force that we just find it out, which is 150. So the answer will be 750 Newton. Clear? Salma, is it understood? Muhammad, send me if it understood. Okay, no problem. تمام. شكرا يا محمد. شكرا يا إلاف. Yes, الله يسعدكم يا رب. Good. Later on. تمام. Last part. What they said. The lift reaches a steady upward speed. Balance or not balance? When they say the steady upward speed, that means it's what? It's balanced. Bravo. The resultant force equals 0. Yes, it is balanced. So state, yani you know the answer. State the value of the force exerted, okay, on the woman by the floor at this steady speed. How much the normal now in this situation, which is when it is moving upward at steady speed? The normal upward and the weight downwards, what they are? They are now what? Equal. So how much the normal reaction upward? How much is the force exerted by the woman upwards? Exactly, Muhammad. Exactly, Hassan. Shukran la'ilku. 600 Newton. That's why they say the word state. That means you already know the answer. 1 mark, 600 Newton. Another mark, 600 Newton. A third mark, 600 Newton. A fourth mark by adding the 600 Newton plus the resultant force. Look how many marks on the answer, the same answer, 600 Newton. You have to look to the question. You have to understand the question to get it correctly. Tamam? You have to make it easy, not complicated. You have to realize the question. تمام؟ بالعربي دائما بنحكي فهم السؤال نصف الإجابة. لما نفهم السؤال نقدر إيش؟ نجاوبه. أوكي؟ تمام؟ كان عندنا homework اللي هو أنا أعطيتكم إياه. أوكي؟ اللي هو triple I for this question. Okay? Question 11. I add a triple I part. We are going to get any new lessons today. We are still going to answer questions about the same topic. Okay? بدي اياكم تكونوا فاهمين هذا التوبيك 100%. Question number 14. It's a homework. Question number 14. It's a homework. تمام. Let's move on to question 15. Let's move on to question 15. Question 16 also homework. Okay. Yes. Question 15. What they said. يلا مع بعض. Okay. An experiment is carried out to find the acceleration of what? Of a free fall. How much is the acceleration of free fall? How much? Approximately 10, right? 10 meters per second square. Exactly. Okay. So our final answer here, how much is the acceleration? It's supposed to be 10, right? Okay. An experiment is carried out to find the acceleration of free fall. Yes, 14 and 16 are homework. Yes. Mister, the paper ends at question 13. Which paper? I will send it to you back. Okay. هلا بعت لك اياها مرة ثانية البيبر من اول وجديد. لا مش paper 13 لسه اكثر. اوكي. حبعت لكم اياها اشوف بالله اذا موجودة عندي ابعت لكم اياها مرة ثانية لان انا متأكد انه Okay. Now, what they said in question 15. شكرا يا أدهم. I know. Okay. مش مشكلة. في مشاكل بالواتساب بدول الخليج حاليا. Okay. تمام. An experiment is carried out to find the acceleration of free fall that we said it's supposed to be 10, okay, on Earth. A strip paper. What is the strip paper? The strip paper, they use it, okay, to describe the motion by knowing the relationship or the distance between the dots that it leaves, the ticker on the strip paper, okay? strip paper is attached to a heavy object. Heavy object, that means does not affect by air resistance, okay? So the object is dropped, initial speed is 0, and falls to the ground, okay? Pulling the paper strip through a timer. There is a timer that makes a tick, okay? Make a clut, make dots, make a mark. The timer mark a dot on the paper strip at every 0.02 seconds. It strikes 50 times, 50 dots every second. It's very fast. Okay? Tamam. The figure below shows a section of the graph strip with what? اوكي طيب نعيد مرة ثانية. A strip paper, okay, is attached to a heavy object and it's dropped and fall, okay, toward the ground. Pull the paper strip with a timer, and the timer ticks and makes a marks of how much 0.02 second each. Okay. The figure below shows this a section of the strip paper, the first 3 dots marked. Okay. The first dot, this one, is labeled A. That means here the initial speed at this point A is 0. Okay, no problem. Okay, now is marked at the instant that it was dropped. State, that means you already know how to explain. State how the dots, okay, of the paper strip show that the object is accelerating. Yes, how the dot show us that the object is on acceleration? Yes. Yes. How can we say that the object is on acceleration? Yes, send it to me. Yes. By the distance between the dots. Bravo. What about the distance? Look, the distance in the first 2 dots. It's only what? 0.019. But the distance from here to here becomes what? Becomes more. Exactly. So as the distance is more, that means the speed is what? Increases. Because look here. If the strip paper was having the dots like this, if the dots have the same distance like this, what that means? That means this object is moving at what? At constant speed. It's moving at steady speed, constant speed, because every time the distance traveled is the same. But if the dots was like this, that means the object is what? Is on acceleration, because the distance traveled every instant, every dot, every 0.02 second, what it becomes what more. So that means it's on acceleration. But if the dots was marked like this one, okay, it was far point, then the points get what? Closer and closer, and eventually like this. That means it's slowing down. Yes, shukran ya Elif, bravo alayki. So here, what we are going to say, the dots get further. The dots, I'm sorry. The dots get further. So the speed increases. So the speed increases. شكرا يا إلاف. طيب. Part B. Calculate what? The average speed. Now the speed changes. It was 0, then I don't know how much it will be here. I don't know how much it will be here, but the speed increases since it changed. They ask about the average speed. The average speed where and when? They ask about the average speed in the first 0.02 second and in the second 0.0 second after it falls, after it dropped. I need to find the average speed from 0, the initial speed here is 0, to this point. That means I will find the speed in the middle approximately. Okay, tamam. I'll find the speed approximately in the middle, because the speed here is 0. The speed here has high value. I don't know how much it is, but I'm finding the average speed since it accelerates. So the average speed is somewhere the speed where in the middle. So we know that speed is equal to distance divided by time. And the distance here is 0.0019 divided by the time, which is 0.02, and the answer will be how much? 0.095 meters per second. So this is the speed approximately in the middle between the first dot and the second dot, the average speed in the first 0.202 second time interval. The second, from this point to this point, from the second point to the third point. So that means I'm trying to find the average speed somewhere here in the middle. Okay, I don't know how much the speed in the beginning, I don't know how much the speed in the end, but I can find the average speed since I know the distance and I know the time. So speed also here equal distance over time. So the distance is 0.0076, the whole distance, minus the initial distance, 0.0019. All of this divided by the time, which is 0.02, and the answer will be 0.285 meters per second. So I find the speed here in the middle, okay, and I find the speed in the middle between the second and the third point, which is approximately 0.285. That's the average speed. I find the speed in the middle of between the first and the second dot, which is approximately 0.095. Okay, now what they ask, use your results, use these results to calculate the acceleration of free fall. How can I do the acceleration? I know that the acceleration is equal to how much? How much is the acceleration? What's the formula for acceleration? Acceleration equal v minus u divided by t. Can I assume that this is v and this is u and the time is, let's say that from here it's 0 to here it's 0.2, that it's half of it, so this is 0.1 from here to here, 0.01, sorry. And from here, from the second dot to the middle, it's also another 0.01. So the total time is 0.02 from this point to this point. Or I can do the same thing from the beginning here. The initial speed is 0. And I said 0.2 plus 0.1. So the total time is 0.3. Okay. Or you can do whatever you want. So I can do this question by several ways. I can say that it's 0.285 minus 0.095 divided by 0.02, okay, and the answer will be 9.5, which is approximately 10 meters per second square, okay? Or I can start from beginning here, from u equals 0, and the time, it's 0.2 plus 0.1. You can do that, yeah. Or you can say that 0.285 minus 0 divided by the time, which is 0.03, and you will get the same answer. So both answers, they give us the same thing. Bravo يا إلاف. تمام. شكرا لكم. Okay. طيب إذا مرة ثانية أنا طلبت منكم homework question 14, another homework question 16, okay, and question 11. I ask a part of the question, or question 12. I'm sorry. Question 11, yes, question 11, a part of question we added to estimate the total height. I want from you to do these 3 questions, inshallah. Okay. Yes, I'm going to show the diagram. Okay. And we are going to finish our class today at this point. Okay. I want from you to study again and try to answer the whole questions from beginning. Okay. Tamam? Mashi? Okay, that's it for today. If you have any question, you can stay online. If you don't have any question, you can leave. السلام عليكم ورحمة الله وبركاته. أتمنى لكم كل التوفيق. الله يعطيكم العافية. أهلا وسهلا. أهلا بكم. أهلا يا حازم. شكرا يا ساندرا. الله يعطيكم العافية. شكرا إلاف مع ألف سلامة. If you have a question, stay. I'm waiting. ها. مع السلامة. Bye bye. If you have any question, I'm staying
Thank
with
you,
you.
sir.
Welcome, welcome. يعطيك العافية حبيبي.
Bye.
مع ألف سلامة.
I have a question on 10B.
10B. Okay, let's move back to 10B. Let's move back to 10B. Yes, what about it? I or double I?
The test 2 for it was one uniform acceleration. I didn't understand it.
Yes, test 2 was one uniform acceleration because here, test 1, as you can see, it has acceleration, or sorry, deceleration from P to Q has different value from where? From Q to R. While test 2 has one part of deceleration that doesn't change. It's a straight line directly from beginning to the end. It doesn't change. So that's why I didn't write it down in the beginning. I write it as third option because it's clearer that test 2 takes longer time, clearer that it covers more area, more distance, okay? But it doesn't matter if the deceleration is changeable or not, but it's different. The deceleration test 2 from test 1 by these three things. State two ways in which the deceleration during test 2 is different. How it is different? By these three things. Good? تمام يا إلاف. الله يعطيك العافية.
But can we say like test 2 was constant deceleration?
Yeah, test 2 was constant deceleration, one part of constant deceleration, not two different parts from P to Q, then Q to R.
Okay, all right.
Okay. ماشي. يلا يعطيك العافية. سلام. مين معانا كمان؟ الله يعطيك العافية. يلا سلام.